Welcome to qnawire.
Okay, we've got some images of burettes, and we've got to report what the reading of those burettes should be, and what the volume would be, plus or minus the uncertainty. We're told that the tolerance is plus or minus 0.05 milliliters. Now, one thing to remember about burettes is that they are actually labeled uh, as how much has been dispensed, right? So if this is the top of the burette, this is 0, and then the bottom of the burette is labeled 50, right? So if your water level is at 10, right, you've dispensed 10 milliliters. Therefore, the volume of that you've dispensed is 10, right? But then the volume of what's remaining in the burette is 40. So just an important thing to remember. Let's see, we're measuring the volume of the titrant, so I assume what they want is this number, but it's worth considering that they may want that number. It's, so whatever we decide the reading is, you can just do 50 minus that reading and maybe include that as well, just in case that's what they want. Okay, let's get on to it. Plus or minus 0.05 is the milliliters. Okay, so we've got 9, and then there's 10 here, and there should be 2, 3, 4. So this is 5. 1, 2, 3, 4. Now this long dash, that is 9.5 milliliters, right? Okay. So where are we at? We are in between the 6th and the 7th. Right. So to me, that looks like 9.65. Right. And we should be able to include, right? So like if it were here, we'd say 9.70. If it were here, we'd say 9.60. But we've got to include this third digit. So we have to estimate whether it's closest to one of these three. All right. But I would say on that image, it looks closest to being halfway between the 0.6 and the 0.7 etching. So 9.65, and then we include the tolerance plus or minus 0.05 milliliters. Right. So that would be the reading there. Let's take a look at the next one. Let's see, the important parts here are that we've got 24 and 25. We should have 1, 2, 3, 4 there. 1, 2, 3, 4 there. And yeah, that's 24 mils. And let's see, we are, in my opinion, we're past the first marker after 24. We're past 24.1 and close to 24.2. So right, we're in between 24.1 and 24.2. And we've got to estimate whether then we are closest to 24.1, 24.15, or 24.20. Okay, and let's see where the line is. To me, again, it looks, remember, and we are measuring from the meniscus. You want to measure from the bottom of the meniscus, right? So you take your reading right there. You don't take your reading right there, right? Okay, so that meniscus appears to be halfway in between 24.1 and 24.2. That's here, right? Because the image is basically like that. So that looks like 24.15. And so we would report 24.15 plus or minus 0.05. And that is in milliliters. Now recall that if they want to know how much is in the burette presently and not how much has been dispensed, then in fact the reading that we want is 50 minus 24.15. Right, so we're going to get 25.85 plus or minus 0.05 milliliters. This is how much liquid is actually in the burette. Similarly, here we would report this if we wanted how much liquid is in the burette. We'd do 50 minus 9.65, and we'd get 40.35 plus or minus 0.05 milliliters. Oh, I misunderstood the question. I see. They want to know how much has been delivered, so they're talking about the initial versus the final reading. Right. Okay. So in that case, that's funny. That's pretty funny. Okay. Well, in that case, then we need to take this 9.65 plus or minus 0.05. And we need to take our 24.15 plus or minus 0.05. So we'll have to do the difference of these. This is how many has been dispensed. So 24.15 minus 9.65. Right, and we'll get 14.50. Fairly certain. Yeah, that looks right. And then we need to consider the uncertainty, right? So the equation for uncertainty when you're adding things is that you can simply take the error from one measurement, and that should be the error for the measurement delivered, right? So this is still just plus or minus 0.05, right? We don't need to like add the uncertainties or propagate the uncertainties. If you were to use the burette multiple times and take the sum, then you would have to worry about error propagation. But in this case, it can simply be plus or minus 0.05. So the final answer is that.